Hello and welcome to Chapter 16, Solubility, Equilibria. We're in the middle of the chapter here on page 4 of our notes, and we're just finishing up that problem from class. So let's go back and see what we did. We already did this one. Here we were. So we mixed 150 mils of 1 times 10 to the negative 2 molar magnesium nitrite with 250 mils of 1 times 10 to the negative 1 molar sodium fluoride. We made our net ionic equation. We determined that our Mg plus 2 and our F minus were what were producing our solid here. So we plugged in the milliliters times the molarity in order to get our concentration over our total volume here in order to get out some molarity. So we solved for moles here, and then or millimoles rather, and then we put it over our total volume to get out both of our molarities and compared it to our KSP. Well, we determined that our Q, or our solution, was greater than our KSP, so we would have some precipitate form. Then we had to kind of cancel out our solids from solution. So we took that same net ionic equation we found, converted to millimoles again, or you could have just transferred over your answer from the top of your equation and plugged them into our stoichiometry box, subtracted the lesser amount, not forgetting to multiply by 2 here, and we got out 22 millimoles of our F minus because our Mg was our limiting reactant. Then we found the concentration of that over our total milliliters. Now that we have that, we know that what's left over in solution is our F minus. We're going to use that in an ice box as our initial concentration. Okay, so this is what we got through in class. So now let's put it into an ice box. We're going to put that 5.5 times 10 to the negative 2 from our last calculation in with our 0. Well, it's still going to shift this way because we have a 0. Don't forget that this will be 2x thanks to our 2, but we can use the 5% rule and cancel out our x here. Now we're going to use that KSP that was given to us in the problem and put that equal to the one that we came up with, plugging in our x for our Mg plus 2 and our molarity for our F minus. Don't forget to square it. Solve for x here by just dividing. And we got out 2.1 times 10 to the negative 6 moles per liter. But what does that actually tell us? That tells us that our concentration of magnesium was 2.1 times 10 to the negative 6, and our concentration of our F minus was what we solved for in our last stoichiometry box. So essentially what we did here was we negated what came out of solution as a solid. So we got rid of our precipitate, and we determined what would be actually in our solution when it was saturated. Remember, saturated means on the line in a graph. So try this one, and we will go over that in class tomorrow. Try this guy out. Same process as the last one. One more thing to talk about here. We touched on this a little yesterday. If I want to selectively precipitate something, I will use a reagent whose anion only forms a precipitate with what I want to get out. Okay, so for example, I have a solution with some barium and some silver. If I add salt, that salt will form a precipitate by breaking up in solution, and the chlorine will bond with the silver. And it'll make some AgCl that'll precipitate and leave that Ba2+ in solution. Also, my Na would still be in solution. So here's the type of problem we could see on that. Solution contains some 1 times 10 to the negative 4th molar copper and 2 times 10 to the negative 3rd molar lead. If we add some I negative to this solution, we want to know which precipitate will occur first, my lead iodide or my copper iodide, and it gave me 2 KSPs for those guys. I also want to know what concentration is necessary for each salt to be precipitated, because maybe I want to precipitate all of one out before I precipitate the next. This is really applicable to real life. Here's how I'd approach this problem. Figure out my 2 net ionic equations. My first one's going to be forming that lead iodide would come from Pb plus 2 and some I negative, but I need 2 of those I negatives. I can make my KSP from that. Remember, this isn't perfectly correct. I needed to put aqueous beside these, because that told me to leave this guy out and keep these in my KSP. Then I'm going to plug in my KSP here, and plug in my known information here, because that's how much my PB gave me, 2.0 times 10 to the negative 3. What did the question ask? It wants to know how much I negative I'll need. Okay, so I'm solving for my I negative in this question, and I can do that by just dividing by this guy, taking the square root, and getting out 2.6 times 10 to the negative 3 molar. So that's the amount I would need in order to form this precipitate. Now I need to do the same thing for the other side. Figure out my net ionic. If this was totally right, I'd put some aqueous in here. Make my KSP. Solve for it the same exact way. What number am I going to put in for my copper? I'm going to go up here and figure out how much copper I put in initially. So 1 times 10 to the negative 4th. Plug that in. Solve for I the same way. And I got out 5.3 times 10 to the negative 8 molar. Well, this tells me which one will precipitate first, because which one is a lower amount. Okay, I need less of my I negative in order for it to bond with some copper and make a precipitate. I need more of my I negative for my lead to bond with my iodine. Okay, so we're kind of thinking opposite of last time. What we're saying here is it requires a very small amount of I negative for this reaction comparatively to this reaction. We're not done yet. Oh, I guess we are. Okay, so we answered both questions. We determined that the CuI would form first, and, oh, the second part of our question was how much is necessary. Well, this is how much was necessary for it to occur. So I could put this much in and go up to this much in order to get all my copper out. And once I get to this amount, my lead is going to start forming. Okay, good. So try this one. This is not in your notes, so you might want to pause it here because I added this in for you to try. So you have 2 problems that you should try tonight, and be ready to go over those tomorrow, because we are definitely moving on to our last chapter tomorrow. All right, see you later.